Today, we are diving into a material that sounds like something straight out of science fiction. It's so thin, so strong, it's completely changing our idea of what protection can be. We're talking about graphene and how it's being used to engineer the next generation of armor. So let's just start with the big question, right? How do you make a piece of armor, well, practically invincible? You see, it's not just about stopping a projectile one time. It's this constant, brutal war against friction, against rust, against all the elements. The challenge is just huge, and it's going to take something way more sophisticated than just adding another thick plate of steel. And this really is the ultimate armor challenge. Modern protective gear, especially on vehicles, is in a constant battle with forces that just never ever let up. Think about all the enemies that armor has to face. Yeah, of course, you've got ballistic impacts. That's the one we all think of first. But just as dangerous, you've got the constant wear and tear from moving parts. You have the silent creep of corrosion that can weaken a structure from the inside out. And then there's just the slow, steady decay from being out in extreme environments. Any single one of these can be a critical failure. The real goal is to defeat all of them at once.
So, how in the world do you fight all those different enemies at the same time? Well, scientists are turning to what many call a true wonder material, graphene. And believe me, this isn't just a minor upgrade. It's a completely revolutionary leap forward.
So what exactly is graphene? At its heart, it's almost laughably simple. Just picture a single sheet of carbon atoms. Yep, the same stuff that's in the graphite of your pencil, but it's only one atom thick, arranged in this perfect, beautiful honeycomb pattern. It is literally the thinnest material known to science, and yet it's also one of the absolute strongest. And that super simple structure? It gives it some genuine superpowers. We're talking exceptional mechanical strength, way, way stronger than steel. It's incredibly stable chemically, so things like rust just can't get a foothold. Get this, it is so impermeable that not even a helium atom, the second smallest atom there is, can squeeze through it. And finally, it has a high aspect ratio. That just means the tiny flakes are really wide and flat, so a very small amount of it can cover a huge area. It's like the perfect resume for a protective coating.
Okay, but here is the really crucial part. You don't just, paint a vehicle with a pure sheet of graphene. This wonder material needs to be part of a team. The real magic happens when you mix it into another material to build a true supercoating.
This quote from the research just nails it. Graphene acts as a nano filler. Think of it like this. You know how builders put steel rebar inside concrete to make it way stronger? Graphene does the same thing, but on a microscopic scale. These tiny little flakes get mixed into a base material, a matrix, and they create this composite that is so much stronger than either part could ever be on its own. And choosing that base material, that matrix, is a really strategic decision. It all depends on what you're trying to protect against. Do you need something flexible that can absorb a big impact? Well, then you might embed your graphene in a polymer, something like epoxy. Or do you need extreme hardness and super low friction to fight off constant wear and tear? In that case, a metal matrix, like copper, is going to be your best bet. Each choice really tailors the armor for a very specific job. And the results? They are just mind-blowing. Take a look at this number. One study found that by adding what's called functionalized graphene, that just means it was tweaked a bit chemically to bond better, to an epoxy coating, they saw an 84% improvement in impact resistance. 84%! That is a gigantic leap in survivability. But if you thought that was impressive, it gets even more dramatic when you look at wear resistance. Research on copper graphene coatings reported a reduction in wear volume of more than 99%. The graphene basically acts like a solid lubricant at the nanoscale, just slashing friction. It's almost like making friction disappear entirely. It's incredible. And the innovation doesn't even stop there. Scientists are now building what they call hierarchical structures. They're combining graphene with other amazing nanomaterials, like carbon nanotubes. It's like building a shield not just with bricks, but with reinforced bricks, held together by an intelligent mortar. It's creating layers of defense at a microscopic level. Okay, so let's say you've done it. You've designed the perfect supercoating. It's strong, it's slick, it's everything you want it to be. But all that amazing science means absolutely nothing if the coating just peels off when it's put under real-world stress. So the next massive challenge is making sure this stuff actually sticks. And getting it to stick requires this incredibly careful, high-tech process. First, you have to prepare the metal surface itself. They use things like plasma treatments to rough it up on a microscopic level, just to give the coating something to grab onto. Next, you build the coating layer by layer, using these ultra-precise methods like cold spray. And finally, you fuse it all together. You might use something like a laser to create a dense, seamless, and perfectly bonded protective skin. So when you put it all together, you've got the wonder material, the smart composite design, and this advanced application process. You start to get a really clear picture of what the future of protection looks like. So what is the real-world impact of all this? Well, it's this powerful chain reaction. Because the armor becomes so much more durable, the vehicle needs way less maintenance, which saves time and money. And that increased durability and readiness translates directly into the single most important thing: higher survivability for the people inside. As the researchers themselves conclude, this isn't just some theory in a lab. These strategies, combining these nanomaterials with sophisticated engineering, are the actual foundation for the next wave of high-performance protection. This is happening right now, and it's setting a completely new bar. So this technology is clearly set to redefine military armor. But that leaves us with one last, really fascinating question to think about. If you can make a tank nearly invincible to wear and tear, what happens when these same ideas are applied to the everyday things in our lives? The cars we drive, the phones we carry, maybe even the buildings we live in. The possibilities are, well, they're absolutely extraordinary.